Here is our problem. How long is the coastline of Britain? And that seems like an easy question to answer. How long is a coastline? That seems straightforward. It's actually a lot more complicated than you think, because the problem with the coastline, this is what they noticed, is that the smaller the scale that you use, the longer the coastline seems to get. So in other words, if you measure a coastline in miles, you might get 500 miles. If you measure it in feet, you're going to get a number that's actually bigger than 500 miles. It might be more like 700 miles. Because coastlines are a lot like fractals. And that's what they found out, that there's a lot of similarities between a coastline and a fractal. Because as you zoom in, as I zoom into this coastline, it's still going to look roughly the same. It's going to kind of jut out, goes in places, goes out places. So no matter what your scale, the coastline, it looks roughly like the same complexity, I guess is what I'm saying. So no matter what your scale, it has the same complexity. So that makes it a fractal. It's like a self-similar shape. You can see itself. As you zoom in, you keep seeing the same pattern repeated. The pattern is all this jaggedness right here. That's the pattern that's always being repeated as you zoom in and zoom in and zoom in. So how long is the coastline of Britain? Classic problem here. Now, to kind of figure this out, what I'm going to ask you is, given a certain scale and given the initial distance, like in this case, 600 kilometers is the straight line distance from Edinburgh to Ipswich. So given this, and then given the scale you want to use, in other words, how long is your measuring stick going to be? That's the scale. How long will the actual coastline be? So to answer a question like that, we have to talk about something called a fractal dimension. And I'm going to just start with an easy example here. Let me kind of put a line, because right now we're just talking about the Koch curve. So the fractal dimension of the Koch curve. And fractal dimensions are kind of cool, actually. Usually dimensions, you think of something that's like one-dimensional, two-dimensional, three-dimensional, okay? They're whole numbers, right? Well, it turns out, the definition of dimension can be used elsewhere. And you get dimensions that are not whole numbers. So a fractal dimension could be something like 1.6, 1.313. Okay, that's a fractal dimension. It's kind of a, not necessarily a measure of complexity. Well, that gets complicated. Exactly what it means gets a little complicated. It's a little bit beyond this. But you can think of it as being how jagged is something. How kind of like how complex it is, but not quite. But let me show an example so that you know what I'm talking about. So let's look at the fractal dimension of the Koch curve. And if you look back on the Koch curve, it looked like this. All right, so at the first iteration, n equals 0. Okay, we didn't do anything. It's a straight line. Then we applied our first fractal transformation here. I replaced the middle, replace it with 2 equal sections. That way I have 4 equal sections. So this is the curve that we're going to look at first to figure out what the fractal dimension is. So if I look at this curve at n equals 0, I just need 2 iterations next to each other. I could use these two, or I could use these two. I could use any two that are right next to each other. I'm just going to start with these. The numbers are nice and easy. So I'm going to use those two. All right. Now, let's see here. It started at 1/3. So I cut it into thirds on the first time, right? I just chopped it into thirds. I didn't do anything with it yet. That first iteration, that's where I rearranged them. I rearranged these pieces. I had to add an extra one in there. So it ended up with 4. So 1/4. Now the exponent that you have to use to get from the smaller number to the bigger number, that is your fractal dimension. So D is the fractal dimension. This is what I need to know, the fractal dimension. I need to know this to figure out how long a coastline is going to be if I change my measuring stick, if I change the scale. So d is the fractal dimension, and it's basically based on a log over log curve. So basically log of 4 over log 3 will get you the fractal dimension here. Okay, that's called a log over log curve. I'm not going to go into detail about how I got to there, but just know that's where it's coming from. All right, so that's the fractal dimension. And now I need to know a way of figuring out what the length is. So if I look back here, total length for the Koch curve, we had this nice little formula here. This is what you used on the last homework. All right, so if I'm going to use that formula, so it's L equals L naught times 4 to the n over 3 to the n. Now, this I can rewrite, because 4 is basically, it's like the new length. Or, well, it's not the new length. It's how many new segments do I have. This is how many segments I end up with. I don't know how many segments. For this length, if you tell me, well, what is it if my scale is going to be 100? Well, I don't know how many 100s are going to fit in here ahead of time. I don't know that information. But I do know what I started with. I started with 600. Okay, I did start with that. So this bottom number, I can keep that. I know how many lengths I can fit in a straight line, in other words. Now, this number, I don't know, but I do know that 3 to the d power will equal 4. So 3 to the d will get me 4. All right, so I can rewrite this here. L naught times, I'm sorry, not 4. I just told you how we can get 4. 3 to the d to the n power divided by 3 to the n. And if you're confused, it's okay. Just slow it down. And I'll give you a nice pretty formula at the end. All right, so I have that so far. Now, I don't know what n is. I mean, how many iterations is it going to take me to fill it in? That I don't know ahead of time either. But since basically I can rearrange some of this here, because we said that if you look at the old one, we said that the scale, that's the length of your measuring stick, is going to be L naught divided by 3 to the n. So that equals L naught divided by 3 to the n. Well, I can use logarithms, and I can figure that out. That's just going to be n after some algebra. So n equals log. All right, so that's the logarithm of base 3 to L naught divided by 6. I'm sorry, L naught, yeah. 18, let's see, 18, or my new length is going to be 6, yes. Okay. Now, this actually works out to 1. Because 3 to the first power will get you back to 3, right? So this is just 3. So n equals 3. So I can cancel the n's out. Also, 3 to the d divided by 3, well, if you think of your exponents, there's an imaginary 1 right here. So when you divide exponents, you have to subtract them. So this exponent, I can combine all this stuff and just say 3 to the d minus 1. So L equals L naught times 3 to the d minus 1. So I can use this formula, and I can figure out what's the new length. Now, let's kind of fill this in a little bit more, make it a little bit more general, because we're not talking about the Koch curve. We are talking about the British Isles. Okay, so I need to make this more general so I can carry this over to this. So let's see here. I could rewrite this. I can say, or L equals L naught times L naught divided by S. That's the scale that I want to use to the d minus 1. Okay, that's this very important formula here. And I just covered up something important. That's d minus 1. Hopefully you have some audio. That's d minus 1. All right, put some stars around it. That's an important formula, because that's the formula that you're going to use right there. That's what you're going to use for the homework. And just so you know, so L naught equals the straight line distance L equals the new distance, which is longer, the new longer distance. And then S, well, that's my scale. So that's the scale. It's the length of your measuring stick. Length of measuring stick. See if I can fit this without going over. Okay. So S is the scale. L is your new length. That's what you're looking for. L naught is just the straight line distance. Like here, between these two cities, L naught is going to be 600. All right? L naught is 600. So let me do an example here. So this is like the kind of stuff you're going to see on the homework, all right? So make sure that you at least watch this part. So if the straight line distance, so straight line distance between, let's see, we have Edinburgh and Ipswich. And I choose these two cities because they are along the coast. You want to choose two cities that are along the coast because I'm looking at this line right here. I want something that's on the line. All right, so that's why they're on the coast. If the straight line distance between these two cities is 600 kilometers, what is the length of the coastline What is the length of the coastline if the scale is 100 kilometers? Okay, so if my scale is going to be 100 kilometers, if I'm using measuring sticks that are 100 kilometers long, what are they going to add up to be? Okay, I'm adding up those 100 kilometer long measuring sticks to figure out what my new length is going to be. Obviously, this coastline is longer than just 600. Okay, so to know this, I have to know my fractal dimension. And I will tell you the fractal dimension. So D equals, well, not equals, that really I should say about. It does change a little bit. So it's about 1.25. And I will tell you on the homework what the fractal dimension is to use. All right, so it's about 1.25. So let's look at our formula here. This is what I'm going for. This is what I have to use. L, that's my new length. That's what I'm looking for. So let me just copy it on down here. I'll move my paper up a bit here. So just let me copy the formula. L equals L naught times L naught divided by your scale raised to the D minus 1 power. So all you got to do is just fill it in. So L naught, well, that's just my straight line distance, which we said was 600 kilometers. So that equals 600 times, well, I have 600 up here, divided by my scale. What's my length of my measuring stick here? Scale is 100. So 600 divided by 100 to the D minus 1. D is 1.25. 1.25 minus 1. All right, so all this is what I put into the calculator. And if you put that into the calculator, you get, because I did this just a second ago, let's see here, and we get 939, and it's actually 0.01, I'm sorry, 0.051, don't worry about that, just the nearest kilometer. Right? So if I use a scale of 100 kilometers, so my measuring stick, I'm just putting one stick next to the other, just one next to the other, kind of like this. Boom, 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 boom. Each of these is the same length. That's what I'm talking about, the measuring sticks, okay? Now, if each of these was 100 kilometers long, they would add up to 939 kilometers. So I went from 600 kilometers to 939 kilometers when I used a smaller scale. And of course, if your scale is even smaller, this number is going to get even bigger. Your coastline is going to appear even longer.